Today we're going to be solving for variables, and we're going to start out small and then we're going to start to ramp it up a little bit more. And if we have time, we will do some word problems. Now, I do want to specify these are not my worksheets. We are just finding these on the internet and just kind of tailoring them to our lecture. So first and foremost, when you have any sort of variable that you're solving for, you always want to do the opposite action in order to cancel it out. So if we are trying to solve for h, right, notice that next to h is b, and it's going to be multiplied to b. So the opposite of multiplication is division. So we are going to divide by b here. So h is equal to v divided by b. And you'll see h is now all alone to one side. So now let's try it again with number 2. So go ahead, try number 2. So we're solving for b. It's multiplied by r, and r is kind of like its coefficient. So we are dividing by r here. So b is equal to p over r. All right. Now let's try it again with whenever you have any, whenever you have multiple variables or multiple items that are being multiplied. So you'll again see here r is being multiplied by 2 pi. And this 2 is being multiplied by the pi and the r and so forth. So rather than dividing by the 2 and then having c over 2 is equal to pi r, and then again dividing by pi, and then having to do the keep, change, flip, all of that, why not make your life a little bit easier? As long as they're being multiplied, right, this whole thing being multiplied to r, you can actually go ahead and divide them both together. This way, r is then alone, and you only have to do that one set of division, and you're not going to get as lost. So why don't you try it again for number 5? So h is being multiplied by L and W. So we're going to divide both of those together, and h is equal to V over LW. All right, let's try number 9. Let's try number 9. So we're solving for B. And you can start by rewriting any sort of fractions if you would like. So this equivalent equation could be written as b times h divided by 3. Because think about this, these variables being over 1, if you will, and just multiplying straight across. Now, the reason why I like this form a little bit better is that when you start to bring things over to the other side, it's a little bit easier to see it when you have this division to do the opposite action. So if you're trying to get b alone, one thing you can bring over is your 3. So what is the opposite of division? If 3 is doing the dividing, the opposite of division is multiplication. So we can multiply 3 to the other side. Then we can go ahead and divide by h. This way, they cancel one side. So b is equal, is equal to 3v over h. Now, if you wanted to, you can certainly do them at the same time. This part at the same time, you could say, okay, I'm going to multiply by 3 and divide by h at the same time so that it cancels all out at once. And then what you do to one side, you do to the other. All right, let's try it again for 10. So again, solving for h, you have multiple things being multiplied. You also have a fraction. So let's change that fraction so that it's appearing in the denominator. So once more over 3. Now let's try and actually, if you want to do it slowly, you can multiply stuff slowly over or divide by slowly over. But let's try and do it in one fell swoop. So we're going to multiply both sides by 3. And we're also going to divide by pi r squared. Pi r squared. This way we can cancel out your 3. We can cancel out your pi. We can cancel out your r squared. And you're doing it to the other side. So h is equal to 3v over pi r squared. And the reason why we chose to multiplied by 3 is because the opposite of division is multiplication. And the reason why we divided by pi r squared is because the opposite of multiplication is division, because this whole thing is multiplied by h. Now let's take a look at r. Now in this case, r is in the denominator. So to get anything out of the denominator quickly is to multiply by the denominator. So to multiply by r quickly, we'll get the r out of the denominator. So this is an I and an E. Notice that you're not working with fractions here, but we're still trying to solve for r. So we're not fully finished. So the next thing we have to do is then divide both sides by I, because I is now being multiplied by r. So the opposite of division or multiplication is division. So r is equal to E over I. Right, now let's try it again with, let's see, what's a good one? Actually, let's change this. Let's say we are going to be solving for P. So to kind of do the same thing as we did before, to get P out of the denominator quickly, we're going to be multiplying by P. So you have PV is equal to KT. P is now being multiplied by V, so the opposite of multiplication is division. So P is equal to KT over V. Okay, we'll do just a few more. Let's do 13. So we have AX plus B is equal to 0, and we are solving for X. So the first thing we want to notice is that this is the first time we're seeing something that's being added or subtracted to our value of interest. Now, anything that is added or subtracted without any sort of grouping, then we can actually bring it over to the other side. So let's go ahead and subtract B. Now we're subtracting B because the opposite of addition is subtraction. What we do to one side, you do to the other side. So you have AX is equal to negative B. Now A is being multiplied by X, so the opposite of multiplication is division. Oops, divided by the wrong one. So that cancels on one side. So you're left with X is equal to negative B over A. Let's try it again for 14. Okay, so again, you're going to notice that B is being added. So because there's no sort of grouping, it's not in parentheses or an absolute value or square roots, we can go ahead and subtract B to the other side. So we have Y minus B is equal to M times X. Now M is being multiplied by X, so go ahead and divide that out, do the opposite action. So now X is equal to Y minus B over M. Now let's take a look at 16 below. We have AX plus BY is equal to C, where we're solving for Y. So notice that again, you have something that is being added or subtracted by your term. So we can go ahead and subtract that whole thing to the other side. Now notice that the whole thing can come over because there's nothing in here of any interest. So that those variables can go over. So we have C minus AX, and we're getting closer. Now B is being multiplied by Y, so we're going to divide that out. So Y is equal to C minus AX over B. Now, why don't you try it again with P? Not P, 15. What am I talking about? So we're looking for W. So first thing to go over should be this 2L because there's no variable in there that we need. So we have P minus 2L is equal to 2W. We're getting close. We have 2 being multiplied by W. So then we can go ahead and divide everything by 2. So you have W is equal to P minus 2L over 2. Or you can break it up so that each one has its own fraction. So you could also say W is equal to P over 2 minus 2L over 2, which then allows us to cancel out this 2. The way it's written here, your 2's are not allowed to cancel because really there's 2 fractions going on. And you'll notice that P can keep its denominator. Okay, we'll do just a few more. We might just do 17, 18, and 21. And that might be it. Okay, so let's try this one. So we are now looking for S. Now, unfortunately, the way that it's set up, we are not able to just subtract out this C because it's directly being subtracted by your S. And again, the way that it's written, we cannot just add your S to the other side, right? So we could do one of two things. We can either break this up into multiple fractions, and then we could certainly bring your fraction over and then start to whittle away, but then it's not going to be as simplified. So the first thing we want to do, kind of keep these together, but look at your numerator. You have something in, well, I should say this before I say that. The reason why I think we should keep your write a pair of parentheses is that showing its fractional form, C minus S, right? This whole thing is being divided by your n. So before we can go ahead and break open your parentheses and get to this S, the 1 over n is in the way, right? So your division by n is causing an issue. So how do we get rid of your n? Well, if it's being divided by n, the opposite of division is multiplication. So we can go ahead and multiply n to the other side. Now we can go ahead and drop your parentheses because what we've done is canceled out your n's. So now we have C minus S. Now we can drop the parentheses because there's nothing else we need to account for. So at this point in time, we're trying to solve and get S alone. So we can go ahead and subtract C to both sides. So you have ND minus C is equal to negative S. Now you need to take care of this negative side. So we can do that in one of two ways. You can either divide out this negative by putting a parentheses or a negative and then parentheses around this whole expression to be equal to S, or you can distribute that negative in and have negative ND plus C, or a better structure would be C minus ND. All right, now let's try 19. So same idea as the one before, just a different sort of variation is that before we can get to this R, you have this grouping going on. You have this parentheses. So we could do one of two things. We could either distribute your C or we could divide out your C. Now I'll show you both ways. Let's say we divide, actually no, let's say we break it open. R is equal to C plus CR. And again, we're just interested in R here. So we can go ahead and subtract out your C because it's not something that we need. So we have R minus C is equal to CR. C is being multiplied by R. So we can go ahead and divide by C. So R is equal to R minus C over C. Now, depending on your instructor, they might not allow you to leave it this way because we can simplify. We can break it up into two fractions, C over C, and you'll notice that C over C is another way to write just one. They can cancel and make one. So R is equal to R over C minus 1. Now let's say you did not choose to distribute. So instead, let's say you chose to divide out your C. C is doing the multiplying here, so we can divide it out. That cancels on this side, right? Just as they all cancel over here. So you're left with R over C, and notice that that's part of our answer over here is equal to 1 plus R. And again, we're trying to solve for R, get R alone. So then we can go ahead and subtract 1. So R is equal to R over C minus 1. Now it's up to you on which one you prefer, but you'll notice that this one is a little bit easier. So if there is something in the parentheses that you need, I would suggest dividing it out or multiplying it out before you go ahead and distribute. So let's have you try that skill again with 21. So we are looking for little b this time. And again, as we noticed from before, we might not want to distribute back in, especially if we do have a fraction. Now, I'm going to encourage you all to rewrite that 1/2 as just divided by 2 so that you can clearly see it's doing a division. And from your skills before, we can do multiplication and division at the same time. So to get your 2 to cancel, if it's being divided, we're going to multiply it. And we also have your h multiplied by everything. So we're going to go ahead and divide h. So that allows us to cancel out multiple variables at once and then do it to the same side. So we're multiplying by 2 over h. So we have 2a over h is now equal to b plus little b. And we can drop your parentheses now because nothing has been accounted for. If you chose to do it one at a time, you have to keep your parentheses until the very end. Now you can go ahead and subtract your big B. So little b is equal to 2a over h minus b. And there you have it. So hopefully that's enough for you guys as far as a head start goes. We do have some more worksheets for you. If you need more practice, they have solutions. So good luck.